Figure 4 shows a sketch of the curve with this equation. I think it's actually an ellipse. And we're asked to find dy by dx. So for this, we can use implicit differentiation, differentiate each term. Here I get 2x. Here I need to use the product rule. I personally think it's easier to just kind of remember that you differentiate one, one of the terms that you're timesing times by the other one, then add the first one times by the derivative of the second one without overcomplicating it and calling it u and v. So I'll do this first one differentiated, which will be 2, then times by the second one without being differentiated, and then the first one times by the second one differentiated. So 2y plus 2x dy by dx. Then differentiate 3y squared. I'm going to need the chain rule for this one. So basically I times by the 2 to get 6y, and then I times by the derivative of y, which is dy by dx. And then that is going to equal 0. Right, just need to tidy this up. So I can expand that bracket to make it a minus here and a minus here. I probably would write a whole new line in an exam, but I'm just doing it. I'm just running out of space here at the bottom, so I'm just going to do it like that. Right, now I will write, I'll add 2y and minus 2x from both sides, giving me 2y minus 2x is going to equal, then I'll factorize the dy by dx out, the left-hand side, dy by dx, 6y minus 2x. I could have divided through by a common factor of 2. We're going to have to do that at some point. I haven't done it yet. Right, I'll come up here. So dy by dx is then going to equal 2 bracket y minus x over 2 bracket 3y minus x. Okay, let's divide that through by that 2. And we've got our answer, y minus x over 3y minus x. Nice one. The curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q represent points at the furthest west and furthest east of the origin. Using part A, find the exact coordinates of the point P. Okay, so it's at this point here, well, the tangent is just a vertical line, and so the derivative would be not defined. Okay, there is actually no gradient at that point. So the only way this can be the case with our dy by dx is if the denominator is 0. So x equals 3y, or 3y minus x is 0. That's P and Q, which implies x equals 3y. Another way sometimes people think about it is that dx by dy is 0. So you'd have to swap this around, flip this around rather. So 3y minus x is at the top, and then that fraction would be 0. And again, the top is 0. So I just prefer to do it like this, to be honest, but I've seen people talk about dx by dy being 0. Okay, well, we know that's true, but we don't actually have an x value yet. What we have to do is use the original equation because we know at P and Q that the original equation is satisfied, but we also know that x is 3y. So we can sub in. And it makes sense to sub in for x because then we avoid any fractions. So I'm going to get 9y squared. I'm substituting in for x squared, so x squared is 9y squared, minus 2 times 3y times y, so that's going to be minus 6y squared, plus 3y squared equals 50. So actually this works out quite nicely. I'm going to get 6y squared equals 50. So that means y squared is going to be 50 over 6 or 25 over 3, which means y is going to be plus or minus 5 over root 3. Two values because we have 2 points, but q is above the x-axis, so we'll have a positive y value, whereas y is below, so we'll have a negative y value. So I'm going to reject 5 over root 3 and just say this is q. And therefore for p, we've got y is minus 5 over root 3. You could also rationalize the denominator and write it as 5 root 3 over 3. Now I can substitute back in for x. Remember, x is 3y, so x is going to be minus 5. Right, let me just do that again. X is going to be, I'm just going to times through by 3, so x is going to be minus 5 root 3. Okay, let's just write it as finally as p minus 5 root 3 and minus 5 root 3 over 3. Great. It's a common sort of question that comes up with implicit differentiation. So just be aware of, well, actually, part C is going to test this on the next bit. Right at the very top, which is the furthest north point, that's where the tangent would be just a horizontal line. So actually, dy by dx is 0. So 0 for those points, and then not defined for these vertical ones. And then you typically have to kind of sub it back in. It just tests this on a few things. Sometimes you even get a quadratic that you have to kind of factorize. In this case, it worked out okay. We just had y squared, so we just took the square root. But to find the point furthest north, so briefly explain, there's actually quite a few steps expected for this. So we can set dy by dx equals 0 for the most northern point, which actually implies that y equals x here. And then that's not enough. We then need to say sub back into original equation. It will give us two values to give two values for say x, or we could do it for y. And then in this case, because we're finding the furthest, you know what, I'm going to change it to y, and then I'll take the positive in this case. Take positive value for northern points. Then use to find x. I'm being quite comprehensive here. I just want to make sure that I've said enough. In fact, in this case, they're going to be exactly the same, but that won't always be the case. Okay, good question. Well done.